Hello students of class 10. So this is the continuation video of current electricity. In my previous video we have solved few numericals, and here in this video also we are going to discuss few more numerical questions. I have prepared a notes for you, so I will be sending the PDF also, but before that I will be explaining one by one question so that the concept of this parallel combination and series combination will be clear to you. And in the board exam, generally we see there are one or two questions from this chapter. So I hope after this class you will able to solve any numerical questions based upon current electricity. Okay, so let's start our class today. Question number 1, we have here one EMF E with 2 volt with internal resistance 1 ohm and terminal voltage capital V. Also we have here external resistance, a key and an ammeter, right? So here we have to calculate the reading of ammeter and reading of voltmeter, okay, when the key is open, when key is closed. So this all we have to find. Now we know when this key is open, that means current passing through this circuit will be 0, right? So 0 ampere current will pass. Now as 0 ampere current will pass here, so we will get only the voltage, that is V equals to E, because we have the formula, you see the formula here, V equals to E minus IR, right? So if current is 0 here, so this total term will become 0, so V will be 2 volt. So what will be the voltage when current is 0? So it is 2 volts. So first answer is 2. Okay, ammeter reading is 0, so when key is open ammeter reading is 0 and voltage is 2 volt. Next we need to find here ammeter as well as voltmeter reading when key is closed. Now suppose when this key is closed here, so total current we know total EMF by total resistance, that is small r plus capital R. So E is given 2 volt, internal resistance is given 1 ohm, and here capital R is also given 4 ohm. So from here we can easily calculate the current. So current after calculation you can see we have 0.4 ampere. Now once you calculate the current here, we will calculate the total voltage, that is V equals to E minus IR. Now after substituting all the values here, values of E, I and R, will get 1.6 volt. So therefore when this key is closed, we have a voltage 1.6 volt and current of 0.4 ampere, and when it is open we have current equals to 0 ampere and voltage equals to 2 volt, right? So let's move to next question. In the next question you see we have here a battery of EMF 3 volts supplies current through a circuit in which the resistance can be changed. A high resistance voltmeter is connected across the battery when the current is 1.5 ampere. The voltmeter reads 2.7 volt. Find the internal resistance of the battery. So you see in this question we need to find the internal resistance, and all the necessary elements are given in the question. Like for example, the value of E is given. Now when I say here EMF, that is E is given here, right? I is given here, that is 1.5 ampere, and also the voltmeter reading, that is 2.4 volt, is also given. So these values are given, so we need to find the internal resistance. So we'll use the formula R equals to E minus V by I, right? So after substituting all the values here in this formula, we'll get the internal resistance. We'll move to next question. So question number 3 we have here A cell of EMF 1.8 volt and an internal resistance 2 ohm is connected in series with an ammeter of resistance 0.7 ohm and a resistor of 4.5 ohm. So it is given in the diagram. Now you see what we need to find here. What would be the reading of ammeter? First we need to find the ammeter reading. What is the potential difference across the terminal of the cell? So first we will note down what is given in the question here. EMF is given 1.8 volt. So 1.8 volt here. Now total resistance, you see all the resistance are in series. So therefore 2 ohm, 7 ohm and 4.5 ohm. So as these all are in a same branch, so we'll add those. Okay, so 7.2 ohm it is. Okay, so not watt, and we have to find the current reading. So we know current equals to EMF by total resistance. So after substituting here, we will get the current. Now once we know the current value here, that will be used in the next part, that is, now we have to find the total potential difference across the terminals of the cell. So potential difference, when you find across the terminals of the cell, that means we have to exclude the internal resistance from the total resistance. That means now total resistance only will be 4.5 plus 0.7. okay, so we'll get 5.2 ohm. Now we know potential difference equal I equals V equals to IR, so we'll substitute this value here and we'll get the potential difference across the terminal. Okay, so next question we have question number 4. A battery of EMF 15 volt and internal resistance 3 ohm is connected to two resistors of resistance 3 ohm and 6 ohm in series. Find the current through the battery and the potential difference between the terminals of the battery. So first we will note down again here. EMF is given how much? 15 volt, and 3 ohm and 6 ohm are in series. So as they are in series, so the total resistance will be 9 ohm here. So here you can see total was 9 ohm. Now internal resistance, that is small r, is given here. I equals to E by R plus small r. So E is also given in the question. That is EMF is given 15 volt. Capital R is given 9 ohm and small r is 3 ohm here. Now after substituting here in this formula, that is total current equals to total EMF by total resistance. So we'll get 1.25 ohm. Okay. So next question, what is the potential difference across the terminal of the battery? So same here, the same current will be using here, and external resistance we have 6 plus 3, that is 9 ohm. So this question and the previous question was more or less same. In the previous question we had external resistance as well as internal resistance. So in order to find the potential difference across the terminals, so we will not include any internal resistance, we will only take the external resistance. Okay, so as already given here, 3 ohm and 6 ohm are in series, so external resistance is 9 ohm. So we'll move to next question now. Question number 5. A cell of EMF E and internal resistance R sends current 1 ampere when it is connected to an external resistance 1.9 ohm, but it sends current 0.5 ampere when it is connected to an external resistance 3.9 ohm. Calculate the values of E and R. Okay, so here one by one we will note down. So first, current is given 1 ampere and resistance is given 1.9 ohm, right? So resistance is also given and current is also given. So once resistance and current is given, substituting in equation number 1, that is I equals to, that is total current equals to total EMF by total resistance, but or if you cross multiply, E equals to I R plus R, that means making E as a subject. So we will get equation number 1. In the second case, when it sends 0.5 ampere current and external resistance is 3.9 ohm, so we'll get the other equation. Now when these two equations are solved simultaneous equation, or you equate equation number 1 and equation number 2, we'll get the value of small r. Now this small r, this value of small r, you will substitute in any of the equation, either equation number 1 or equation number 2, so you will get the EMF. Okay, so this is how we'll calculate the EMF as well as internal resistance. So in question number 6, two resistors having resistance 4 ohm and 6 ohm are connected in parallel. As they are connected in parallel, that is 1 by 5, 1 by 4 plus 1 by 6, so we'll have 5 by 12, or if you reciprocally it, we'll have 12 by 5. So find their equivalent resistance. So this was a very simple question. So just we need to find the parallel combination of the two resistance 4 ohm and 6 ohm. Four resistors of each of resistance 2 ohm are connected in parallel. What is the effective resistance? So same way here, we have here 4 resistances, that is 2 ohm each, so 1 by 2 plus 1 by 2 plus 1 by 2, so we'll have 2 ohm, right? So equivalent resistance is 2 ohm here. Next question, question number 8. Here in the question it is given, you have 3 resistors 2, 3 and 5. How will you join them so that the total resistance is less than 1? Draw a diagram and find the total resistance. Now remember this one, whenever resistance are connected in series, the last answer, that is the total resistance, always increases. Now if you want less resistance in the answer, that means you make sure that the resistance are connected in parallel. So definitely we will connect these 3 resistances in parallel, that is 2 ohm, 3 ohm and 5 ohm. They are connected in parallel, and we know parallel combination 1 by R1 plus 1 by R2 plus 1 by R3. Okay, so this was the formula. So when we apply this formula here in this question, we'll find the total equivalent resistance, that is R equals to 1 by 2 plus 1 by 3 plus 1 by 5. Now if you reciprocal it, you will get 31 by 30. Okay, or you leave your answer up to here, or you can find it in decimal also. Both the way it is correct, but make sure you are writing the units. So next question we have here, question number 9. 3 resistors each of 2 ohm are connected together so that the total resistance is 3 ohm. Draw a diagram to show this arrangement and check its calculation. So a parallel combination of 2 resistors in series with 1 resistor. So you see what is given here, 3 resistors each of 2 ohm are connected together, so the total resistance you see here, that is 3 ohm. It has to be 3 ohm. So how much should be there here? So the total resistance should be connected like this. 2 resistors are connected in parallel, okay, and their combination is connected with series with this. Now if you connect 2 resistors like this, that means 1 by 2 plus 1 by 2, you will get 1. The total resistance is how much? 1. And this is in series with 2 ohm, that means this is 2 ohm, and here this combination, this is 1 ohm. Okay, so 1 ohm plus 2 ohm, you will get 3 ohm. So like this we will connect the 3 resistors each having 2 ohm. So 2 will be connected in parallel, and their combination is connected with series with the third one. Next, question number 10. Question number 10, we have here 5 resistors, or sorry, 4 resistors here. So first we will find the parallel combination of this, and whatever answer we will get, that will be in series with these two, right? So R2 and R4, or R3 and R4 are in parallel. Now whatever answer we will get for R3 and R4, that will be in series with R1 and R2. Question number 11. A combination consists of 3 resistors in series. 4 similar sets are connected in parallel. If a resistance of each resistor is 2 ohm, find the resistance of the combination. So 3 resistors are there and they all are connected in series, and like this we have 4 combination. That means in one we have 1 2 3 4, right? Like this 4 resistors are there. So like this we have more 4 resistance. So here we have more 4 branch like this. So what will be the total of one branch? That is 2 plus 2 plus 2, that is 6. Now like this we have 4 branches. So what will be the equivalent resistance? That means 1 by 6 plus 1 by 6 plus 1 by 6 plus 1 by 6. So when you solve this one, we'll get the equivalent resistance, that is 1.5. Okay, so 1.5 ohm is the answer. So next question we have, in the screen you can see one diagram. 2 resistors are connected in series in upper branch, and in a lower branch also 2 resistors are connected, and these all 4 they are connected in parallel. Okay, so we need to find the unknown resistor, that is X, and equivalent resistance is given here 4 ohm. Okay, so equivalent resistance is given here 4 ohm. So we need to calculate here total resistance. So first of all, 4 plus 8, that is 12, and here equivalence 5 plus X. So equivalent resistance is 4, that means 1 by 4 plus, or 1 by 4 equals to 1 by 12 plus 1 by 5 plus X. Oh, okay. Now we'll solve this equation and we'll get the unknown value of X. So this is how we are going to solve this question. So I hope you are understanding these questions, and once you understand, you after completing the video you need to write in your exercise book also. So make sure that if same questions you get in your textbook, so that will be easy for you see for those questions also. So next question will go, you see this network of resistors. So this one we have to solve now. So first of all, this 1 ohm and 1 ohm, they are in series. 2 ohm and 2 ohm, they are in series, right? Now this 2 ohm, when you add this load, then you will get here 6 ohm, and upper you will get 3 ohm. So 3 ohm and 6 ohm, and in between we have 2 ohm. So these 3 are in parallel. So once you solve these 3, now all in the branch, now other they will be in series. That answer will be in series with the other. So let's see the solution first here. So 1 ohm, when you'll see properly here, so 1 plus 1 plus 1, 3, and here this total, when you will add that, you will get 6 ohm. Now this 1, this 3 ohm, this 2 ohm, and here 6 ohm, these 3 all are in parallel. So what is the equivalent resistance? Now here you will get 6 by 6, that is 1 ohm, right? So now here when you will find the total resistance here, this total portion you will get 1 ohm, this is 1 ohm, and this is 1 ohm, right? Now all these are in series. Okay, so here we'll find the total resistance to be as 3 ohm. Okay, so total resistance is here 3 ohm. So likewise we have few more numericals. Okay, so this type of numericals are there, so these are more or less same. We will be going for the new next questions. I will explain those questions which I feel that is important for you. So some questions are there in the note which by looking only you will understand. Like in question number 18, you see, in this network calculate the equivalent resistance between the points A and B. So between points A and B, when I say, so first 2 ohm, now when I say here this 2 ohm, this 2 ohm and this 2 ohm, this all are in series, so total is 6 ohm. Now after calculating these three resistance, now this 6 ohm is in parallel with the 2 ohm here. Okay, so this is how we'll calculate here. That means 1 by 6 plus 1 by 2. So if you reciprocal it, you will get 1.5 ohm. Now similarly in the question again you will find between A and C, between when you will calculate for between A and C, you see this resistor, this resistor and this resistor are in series, this resistor and this resistor are in series. Okay, so as they are in series, so 2 plus 2 equals to 4 ohm, and here 2 plus 2 equals to 4 ohm. Now they are in parallel to each other, that means 1 by 4 plus 1 by 4, so our required answer is 2 ohm. So similarly we will be solving for these questions also. You see these questions are not so tough. So these two are in series, their answer is in parallel with 3 ohm, and their answer is in series with 3 ohm and 3 ohm. So ultimately at last you will get the total resistance. Okay, so likewise we have other questions also, so I have done here the solution, so you will go through the numericals. Okay, so I am not wasting here much time. So total there are 29 questions. Okay, so here you will be looking one by one questions. So few questions are very easy, some questions you will find problem there, but once you see the formula you will understand. It's not sort of that you will be unable to solve those questions. Like question number 26, you see a battery of EMF 15 volt and internal resistance 3 ohm is connected to two resistors 3 ohm and 6 ohm connected in parallel. Find the current through the battery. We have to calculate the potential difference between the terminal of the battery, the current in 3 ohm resistor and the current in 6 ohm resistor. So first of all, in the question it is given here that EMF is of 15 volt, resistance 3 ohm is connected to two resistors 3 ohm and 6 ohm connected in parallel. So this 3 ohm and 6 ohm, they are as they are in parallel, so 1 by 3 plus 1 by 6, that is 1 by 2, or the resistance is 2 ohm here, and internal resistance is also given here 3 ohm, and EMF is given 15 volt. So from here we can calculate the total current from here by using the formula E equals to I external resistance plus internal resistance. By using this formula we can calculate this I very easily. So once you calculate the I here, so what is said here, potential difference between the terminals of the battery, that is V, that is V equals to IR. Again by using V equals to IR, once you know the I value from here, I is 3 ampere and R is 2 ohm, so that is 6 volt. Okay, now once the voltage is 6 volt here, so what is the current in 3 ohm resistor? Now current in the 3 ohm resistor, now voltage remains same in both the resistors here. Now we know voltage is 6 volt and resistor is 3 ohm, so we'll get the current here. And similarly voltage across 6 ohm resistor here, I equals to Vy, again 6 by 6, that is 1 ohm. Okay, so likewise you will go through one by one numericals. These numericals are there. I don't think that you will face any problem, because it is clearly, it is given, it is mentioned here what has to be done here, it is clearly mentioned. So in this question you see, just I will give a hint, these two are in parallel, there is in series with 4, and we have here internal resistance also given, current is also given, and voltage is also given, 2 volt. So by using the formula I equals to total resistance by capital R plus small r, right? Small r is given in the question, this R is given, E is also given, I is also given, right? Now in external resistance here you will have in terms of capital R, one R is there here. So from here you will calculate the small r. Okay, so first you try to solve by yourself in your exercise book. So once you don't get the answer, then you go for the solution. Okay, so likewise you will develop your skill of solving the numericals and all. So it is solved already, I have made it clear for you. So you first try to solve by yourself, then you go for the notes. Okay, so likewise there are many questions are there. These questions also you see the diagram below in figure 8.53 shows the arrangement of 5 different resistance connected to a battery of EMF 1.8 volt. Calculate the total resistance of the circuit and the reading of the ammeter. Okay, so once you have to calculate the total reading of the ammeter, here you have to calculate first the equivalent resistance here. So 10 ohm and 40 ohm, these two are in parallel, and these three are also in parallel. So first we will solve for this. So once you get the equivalent resistance here, so you see 1 by 10 plus 1 by 40 and 1 by 30 plus 1 by 20 plus 1 by 60, right? Now total resistance between AB, so 8 plus 10, that is 18. So from here we got as 8 here, okay, and from here we got 10, that means 60 by 6, that is 10. So 10 plus 8, 18. So equivalent resistance we are getting here 18 ohm. Now we know total current equals to total voltage by total resistance. So you substitute here, from there you will get the ammeter reading. Okay, that is our required answer. So I hope you have understood the numericals here. So more and more practice is required. So more you practice, so more the concept will be clear. And in coming week I will be conducting interactive classes also, so make your doubt ready. So keep your doubts with you, you will be asking when I interact with you through Microsoft Team. Now from the coming classes also the number of classes will be increased, and before time we will complete our syllabus. So don't worry about the syllabus, but whichever chapter or whichever numericals you are solving, make sure you are doing it perfectly. Okay, so now only you practice so much that at last you just have to revise. Okay, and likewise I will be giving the notes and numericals will be solving. So goodbye.